In construction, structural steel and fabricated steel are often used interchangeably. This is a mistake, because confusing them can lead to this: a tiny fabrication error on a structural component, risking catastrophic failure. Beyond safety, this confusion hits your budget with massive rework costs and project halting delays. These distinctions are not just words. They are fundamental to material science, legal compliance, and project success. We will now break down the key differences in what they are, how they're made, and where they're used so you can avoid these critical mistakes. Let's start with basics. What is structural steel? Think of it as the skeleton, engineered with one purpose: to bear heavy loads and form the core framework. Now, fabricated steel. This is not a type of steel, it's a process. It is any steel that has been cut, bent, welded, or shaped for a specific purpose. Here is the key point. Structural steel must be fabricated to be used, but not all fabricated steel is structural. This is the source of the confusion. So structural is a what, a material? Fabricated is a how, a process. Why does this what versus how matter? It starts with chemistry. Structural steel has a fixed chemical recipe to guarantee predictable, consistent strength. Fabricated steel, however, can be made from countless steel grades. The composition is matched to its end use, from boat railings to car body panels. This contrast extends to production. Structural steel follows a heavily regulated process. Every beam and column must be traceable and certifiable for reliability. The fabrication process, however, is about customization. It's where raw steel, structural or not, is shaped into a precise, functional component. The engineer relies on the guaranteed properties of structural steel, while the fabricator ensures the final form meets the design. One cannot work without the other. So we have a standardized material versus a custom process. How does this play out in the real world? The applications are worlds apart. Structural steel's domain is large-scale construction. Think skyscraper skeletons, massive bridge trusses, and industrial plant frameworks. Fabricated steel is everywhere: your car's chassis, surgical tools, and architectural gates. This decorative gate is perfectly fabricated steel, but it is not structural. It doesn't need to meet load-bearing standards. Using structural steel here would be costly overkill. This application difference creates a huge divergence in regulation. Structural steel is governed by stringent, legally mandated standards like ASTM or Eurocodes. General steel fabrication may have quality standards, but they lack the legal weight of structural codes. Using a non-structural grade for a beam is a compliance violation. So if the material is right and regulations are clear, what can still go wrong? It comes down to precision in the fabrication process itself. Modern structural fabrication relies on advanced tech for tight tolerances. CAID and BIM models create digital twins of the structure before a single piece is cut. Remember that millimeter error? In a structural beam, a slight deviation can alter its load-bearing capacity. Robotic welding and CNC machining ensure repeatable accuracy. When precision fails, costs spiral. On-site fixes are expensive, cause delays, and can introduce new structural weaknesses. Getting it right off-site is paramount. Let's bring this all together. We've seen the differences in definition, composition, application, and the high demand for precision. Skyscrapers are possible because the material, structural steel, is standardized. They have unique designs because the process, fabrication, allows for infinite customization. This answers our paradox. The material's composition is rigid for safety, but the fabrication process provides design flexibility. You get reliability and creativity. This also shows why the idea that steel construction is slow is wrong. Precise off-site fabrication makes on-site assembly incredibly fast, often beating concrete timelines. It also explains its efficiency. Steel's high strength-to-weight ratio means building taller and stronger with less material in a smaller foundation. So the ultimate takeaway is this: structural steel is a specific certified ingredient. Steel fabrication is the expert recipe used to create the final dish. Understanding this ingredient versus recipe distinction isn't academic. It is the foundation of safe construction and professional integrity. Confuse the two, and you risk specifying the wrong material, violating code, and introducing errors that jeopardize both budgets and lives. As a professional, engineer, contractor, or fabricator, you are the gatekeeper. Your role is to ensure the right material is chosen and the right process is followed. The difference between structural steel and fabricated steel is the difference between a calculated certainty and a dangerous assumption. Double-check your specifications, verify your materials. Question everything. Your project's success depends on it.